LZSSUnit. Compress and uncompress unit using LZ77 algorithm for Borland, Turbo, Pascal version 7.0 contributor, Eigus unit LZSSUnit, LZSSUnit. Compress and uncompress unit using LZ77 algorithm for Borland, Turbo, Pascal version 7.0. Assembler programmer, Andy Tam, Pascal conversion, Douglas Webb, unit conversion, and dynamic memory allocation, Eigus. Public domain version 1.02, last changed on 30.11.94. Target platforms, DOS, DPMI, Windows. Written by Eigus, aka Mr. Byte, of Fidonet, 2:5100/33, Internet, Eigus at fgate.castle.riga.lv, Eigus at kristin.cclu.lv. Interface #Z+. This unit is ready for use with DJ Murdoch's ScanHelp utility, which will make a Borland.tph file for it. #Z-const LZRWBufSize equals 8192. Read buffer size #Z plus N equals 4096. Bigger N - better compression on big files only. F equals 18. Threshold equals 2. Null equals N*2. InBufPtr. Word equals LZRWBufSize. InBufPsize. Word equals LZRWBufSize. OutBufPtr. Word equals 0. #Z-type #xtwrite proc #xlzsquash #xlzunsquashed proc equals function var read buff var number read word. This is declaration for custom read function. It should read #LZRWBufSize #bytes from readbuff. The return value is ignored. #xtred proc #xlzsquash #xlzunsquashed proc equals function var writeBuff count word var number written word. This is declaration for custom write function. It should write count bytes into writeBuff and return number of actual bytes written into number written variable. The return value is ignored. #Z plus PLZRWBuffer equals $TLZRWBuffer. TLZRWBuffer equals array 0 LZRWBufSize 1 of byte. File buffers PLZ text buff equals $TLZ text buff. TLZ text buff equals array 0 n plus f 2 of byte. p left mom tree equals caret t left mom tree. T left mom tree equals array 0 n of word. P right tree equals caret T right tree. T right tree equals array 0 n plus 256 of word. Const LZSSMEM required equals size of T LZRWBuffer asterisk 2 plus size of T LZ text buff plus size of T left mom tree asterisk 2 plus size of T right tree hashtag z dash function LZUnit Boolean. This function should be called before any other compression routines from this unit. It allocates memory and initializes all internal variables required by compression procedures. If allocation fails, LZUnit returns false. This means that there isn't enough memory for compression or decompression process. It returns true if initialization was successful. Hashtag XLZ done hashtag XLZ squash hashtag XLZ unsquash procedure LZ squash read PROC shred PROC write PROC tier write PROC. This procedure is used for compression. Read PROC specifies custom read function that reads data, and write PROC specifies custom write function that writes compressed data. Hashtag XLZ unsquash hashtag XLZUnit hashtag XLZ done procedure LZ unsquash read PROC shred PROC write PROC tier write PROC. This procedure is used for decompression. Read PROC specifies custom read function that reads compressed data, and write PROC specifies custom write function that writes decompressed data. Hashtag XLZ squash hashtag XLZUnit hashtag XLZ done procedure LZ done. This procedure should be called after you finished compression or decompression. It deallocates, frees, all memory allocated by LZUnit. Note: you should always call LZ done after you finished using compression routines from this unit. Hashtag XLZUnit hashtag XLZ squash hashtag XLZ unsquash implementation var height match POS match len last len word text buff p PLZ text buff left p mom p left mom tree right p right tree code buff array 016 of byte LZRWBufSize shred PROC LZRWBufSize tier right PROC InBufPtr outBufPtr LZRWBuffer bytes word initialized Boolean function LZSS_read word returns hashtag of bytes read begin LZRWBufSize, InBufPtr, bytes, LZSS_read equals bytes, and LZSS_read function LZSS_write, word, returns hashtag of bytes written begin LZRWBufSize, outBufPtr, outBufPtr, bytes, LZSS_write equals bytes and LZSS_write procedure guessC, assembler, ASM guessC, return a character from the buffer return, AL equals input char carry set when EOF push BX MOV BX, InBufPtr CMP BX, InBufPsize JB at guessC1 push CX push DX push D push SI call LZSS_read pop SI pop D pop DX pop CX MOV InBufPsize, AX or AX, AX JZ at guessC2, EOFX or BX, BX at guessC1, push delay D InBufPMOVAL byte PTRES D plus BX pop D inc BX MOV InBufPtr, BX pop BX CLC, clear the carry flag JMP at end at guessC2, pop BX STC, set carry to indicate EOF at end, and guessC procedure pushC, assembler, pushC, put a character into the output buffer entry, AL equals output char ASM push BX MOV BX, outBufPtr push delay D outBufPMOV byte PTRES D plus BX AL pop D inc BX CMP BX, LZRWBufSize JB at pushC1 MOV outBufPtr LZRWBufSize just so the flush will work push CX push DX push D push SI call LZSS_write pop SI pop D pop DX pop CXX or BX, BX at pushC1, MOV outBufPtr, BX pop BX end, pushC procedure init tree, assembler, init tree, initialize all binary search trees. There are 256 BSTs, one for all strings started with a particular character. The parent is tree K is the node N and K plus 1 and it has only a right child ASMCLD push DS pop ES lay D right PMOV D offset right add D, N plus 1, asterisk 2 MOV CX, 256 MOV AX, Nul N mom PMOV D, offset mom MOV CX, N went, init tree procedure splay, assembler, splay, use splay tree operations to move the node to the top of tree. Note that it will not actually become the root of the tree because the root of each tree is a special node. Instead, it will become the right child of this special node. Entry: D equals the node to be rotated ASM at splay 1. Push BX lay BX mom PMOVSIES BX plus dipop BX MOVSI, offset mom plus DCMPSI, null. Exit if its parent is a special node JA at splay 4 push delay mom P add DSI MOVBX ESD MOVBX. Offset mom plus SI pop DCMPBX. Null. Check if its grandparent is special JB at splay 5. If not, then skip push BX lay BX left PCMPDES BX plus SI pop BX CMPD. Offset left plus SI. Is the current node is a left child. Jane at splay 2. Push BX lay BX right PMOVDX ESBX and DMOVDX. Offset right and D. Perform a left zig operation lay BX left PMOVESBX and SIDX MOV offset left and SI. DX lay BX right PMOVESBX and DSI pop BX MOV offset right and D. SIJMP at splay 3 at splay 2. Push BX lay BX left PMOVDX ESBX and DMOVDX. Offset left and D. Perform a right zig lay BX right PMOVESBX and SIDX MOV offset right and SI. DX lay BX left PMOVESBX and DSI pop BX MOV offset left and D. SI at splay 3. Push SI lay SI right PMOVESSI and BX dipop SI MOV offset right and BX. DXCHGBX. DX push AX MOV AX BX lay BX mom P add BX AX MOV ESBX SI lay BX mom P MOV ESBX and SI delay BX mom P MOV ESBX and DX MOV BX AX pop AX MOV offset mom and BX. SIMOV offset mom and SI. DMOV offset mom and D. DX at splay 4. JMP at end at splay 5. Push delay mom PMOV CX ESD and BX pop DMOV CX. Offset mom and BX push BX lay BX left PCMPDESBX and SI pop BX CMPD. Offset left and SI. Jane at splay 7 push delay left PCMPSIESD and BX pop DCMPSI. Offset left and BX Jane at splay 6 push AX MOV AX delay D right P add DSI MOV DX ESD MOV DX. Offset right and SI. Perform a left zig operation lay D left PMOV ESD and BX DX MOV offset left and BX. DXXCHGBX. DX lay mom PMOV ESD and BX DX MOV offset mom and BX. dx lady right p add dax mov bx est mov bx offset right and delay left p add dsi mov est bx lady mom p mov est and bx si mov offset left and si bx mov offset mom and bx si mov bx dx lady right p add dsi mov est bx lady right p add dax mov est dsi mov offset right and si bx mov offset right and d si lady mom p mov est and bx si lady mom p add dsi stisw mov dax pop ax mov offset mom and bx si mov offset mom and si djmp at splay 9 at splay 6 push ax mov ax si lay si left p add si d mov dx essi mov dx offset left and d perform a left zigzag operation. Lay si right p mov essi and bx dx mov offset right and bx dx xchgbx dx lay si mom p mov essi and bx dx mov offset mom and bx dx lay si right p add si d mov bx essi mov bx offset right and delay si left p add si ax mov essi bx mov offset left and si bx lay si mom p mov essi and bx ax mov offset mom and bx si mov bx dx lay si left p add si d mov essi bx mov offset left and d bx lay si right p add si d mov essi ax mov offset right and d si lay si mom p add si ax mov essi d mov offset mom and si delay si mom p mov essi and bx d mov si ax pop ax mov offset mom and bx djmp at splay 9 at splay 7 push delay d right p cmp si est and bx pop d cmp si offset right and bx jane at splay 8 push ax mov ax si lay si left p add si ax mov dx essi mov dx offset left and si perform a right zigzag lay si right p mov essi and bx dx mov offset right and bx dx xchgbx dx lay si mom p mov essi and bx dx mov offset mom plus bx dx lay si left p add si d mov bx essi mov bx offset left and delay si right p add si ax mov essi bx mov offset right and si bx LZSI mom p mov essi and bx ax mov offset mom and bx si mov bx dx LZSI left p add si ax mov essi bx mov offset left and si bx LZSI left p add si d mov essi ax mov offset left and d si LZSI mom p mov essi and bx ax mov offset mom and bx si LZSI mom p add si ax mov essi d mov offset mom and si d mov SIAX pop AX JMP at splay 9 at splay 8. Push AX MOV AX SI lay SI right P add SI D MOV DX ES SI MOV DX. Offset right and D. Perform a right zigzag lay SI left P MOV ESSI and BX DX MOV offset left and BX DX XCHG BX DX lay SI mom P MOV ESSI and BX DX MOV offset mom and BX dx lay si left p add si d mov bx essi mov bx offset left and delay si right p add si ax mov essi bx mov offset right and si bx lay si mom p mov essi and bx ax mov offset mom and bx si mov bx dx lay si right p add si d mov essi bx mov offset right and d bx lay si left p add si d mov essi ax mov offset left and d si lay si mom p add si ax mov essi d lay si mom p mov essi and bx d mov offset mom and si d mov offset mom and bx d mov si ax pop ax at splay 9 mov si cxcmpsi null ja at splay 10 push delay d left p add dsi cmp bx es d pop d cmp bx offset left and si jane at splay 10 push bx lay bx left p mov es bx and si d pop bx mov offset left plus si d jmp at splay 11 at splay 10 push bx lay bx right p mov es bx and si d pop bx mov offset right and si d at splay 11 push bx lay bx mom p mov es bx and dsi pop bx mov offset mom and d si jmp at splay 1 at end and s play procedure insert node assembler insert node insert the new node to the corresponding tree. Note that the position of a string in the buffer also served as the node number. Entry D equals position in the buffer ASM push SI push DX push CX push BX MOV DX 1x or x, ax mov match len, ax mov height, ax lay si text buff p add si dmov al byte ptr essi mov al, byte ptr offset text buff plus dshl d, 1 add ax, and plus 1 shl x, 1 mov si, ax mov x, null push bx lay bx right p mov word ptres bx plus dax mov word ptr offset right plus d, ax lay bx left p mov word ptres bx plus dax pop bx mov word ptr offset left plus d, ax at ins 1 inc height cmp dx, 0 jl at ins 3 push. Delay d right p add dsi mov ax word ptres d pop d mov ax, word ptr offset right and sicmp ax, null je at ins 2 mov si, ax jmp at ins 5 at ins 2, push bx lay bx right p mov word ptres bx and sid mov word ptr offset right and si, delay bx mom p mov word ptres bx and dsi pop bx mov word ptr offset mom and d, sijmp at ins 11 at ins 3, push bx lay bx left p add bx si mov ax word ptres bx pop bx mov ax, word ptr offset left and sicmp ax, null je at ins 4 mov si, ax jmp at ins 5 at ins 4. Push bx lay bx left p add bx si mov word ptres bx dmov word ptr offset left and si, delay bx mom p add bx dmov word ptres bx si pop bx mov word ptr offset mom and d, sijmp at ins 11 at ins 5, mov bx, 1 shore si, 1 shore d, 1 x or ch, chx or dh, dh at ins 6, push si lay si text buff p add si dmov dl byte ptres si and bx pop si push delay did text buff p add dsi mov cl byte ptres d and bx pop dmov dl, byte ptr offset text buff and d and bx mov cl, byte ptr offset text buff and si and bx. Sub dx, cxjnz at ins 7 inc bx cmp bx, fjb at ins 6 at ins 7, shlsi, 1 shl d, 1 cmp bx, match len jb at ins 1 mov ax, si shore x, 1 mov match pos, ax mov match len, bx cmp bx, fjb at ins 1 at ins 8, push cx lay bx mom p movax word ptresbx and simovax word ptr offset mom and si lay bx mom p mov word ptresbx and dax mov word ptr offset mom and d ax lay bx left p movcx word ptresbx and simovbx word ptr offset left and si lay bx left p mov word ptresbx and dcx mov word ptr offset left plus d bx lay bx mom p add bx cx mov word ptresbx d mov word ptr offset mom and bx d lay bx right p mov cx word ptresbx and simov bx word ptr offset right and si lay bx right p mov word ptresbx and dcx mov word ptr offset right and d bx lay bx mom p add bx cx mov word ptresbx d mov word ptr offset mom and bx d lay bx mom p movcx word ptresbx and simov bx word ptr offset mom and simov bx cx pop cx push delay d right p cmp si word ptresd and bx pop d cmp si word ptr offset right and bx jane at ins 9 push si lay si right p mov word ptressi and bx d pop si mov word ptr offset right and bx d jmp at ins 10 at ins 9 push si lay si left p mov word ptressi and bx d pop si mov word ptr offset left and bx d at ins 10 push delay d mom p add dsi mov word ptres d null pop d mov word ptr offset mom and si Nul at ins 11, cmp height, 30 jb at ins 12 call splay at ins 12, pop bx pop cx pop dx pop si shore d, 1 end, insert node procedure, delete node, assembler, delete node. Delete the node from the tree entry, si equals position in the buffer asm push d push bx shl si, 1 push delay d mom p add dsi cmp word ptres d null pop d cmp word ptr offset mom plus si, null. If it has no parent then exit je at del 7 push delay d right p add dsi cmp word ptres d null pop d cmp word ptr offset right plus si, null. Does it have right child? Je at del 8 push bx lay bx left p mov d word ptres bx plus si pop bx mov d word ptr offset left and si. Does it have left child? Cmp d Nul je at del 9 push si lay si write p add si dmovax word ptressi pop si movax word ptr offset right and does it have right grandchild cmpx null je at del 2. If no, then skip at del 1, mov ax, find the rightmost node in push si lay si write p add si dmovax word ptressi pop si movax, word ptr offset right and the right subtree cmpx. Null Jane at del 1 push cx mov cx si lay si. Mom p add si dmovbx word ptressi movbx. Word ptr offset mom and move this node as the root of lay si left p add si dmovax word ptressi movax. Word ptr offset left and the subtree lay si right p mov word ptressi and bxax mov word ptr offset right and bx ax xchg ax bx lay si mom p mov word ptressi and bxax mov word ptr offset mom and bx ax lay si left p add si cx mov bx word ptressi mov bx. Word ptr offset left and si lay si left p. Add si dmov word ptressi bx mov word ptr offset left and bx lay si mom p mov word ptressi and bx dmov word ptr offset mom and bx dmov si cx pop cx at del 2 push cx mov cx si lay si right p add si cx mov bx word ptressi mov bx. Word ptr offset right and si lay si right p add si dmov word ptressi bx mov word ptr offset right and bx lay si mom p mov word ptressi and bx dmov si cx pop cx mov word ptr offset mom and bx d at del 3 push cx mov cx delay mom p add dsi mov bx word ptres dmov bx. Word ptr offset mom and si lay mom p add cx mov word ptres bx mov word ptr offset mom and bx mov cx pop cx push delay right p cmpsi word ptres and bx pop cmpsi word ptr offset right and bx jane at del 4 push si lay si right p mov word ptressi and bx dip pop si mov word ptr offset right and bx djmp at del 5 at del 4 push si lay si left pmov word ptressi and bx dpop si mov word ptr offset left and bx. D at del 5. Push delay dimom p add dsi mov word ptres d null pop dmov word ptr offset mom and si, null at del 7, pop bx pop d shore si, 1 jmp at end, at del 8. Push bx lay bx left pmov d word ptres bx and si pop bx mov d word ptr offset left and si jmp at del 3 at del 9. Push bx lay bx right pmov d word ptres bx and si pop bx mov d word ptr offset right and si jmp at del 3 at end, and delete node procedure encode assembler asm call init tree x or bx mov offset code buff and bx bl mov dx 1 MOVCH, DLX or SI, SIMOV N, F at encode 2, call guess CJC at encode 3 push SI lay SI text buff P add SI DMOV byte PTRESSI and BXAL pop SI MOV byte PTR offset text buff and D and BX, ALINK BX CMP BX, FJB at encode 2 at encode 3, or BX, BX Jane at encode 4 JMP at encode 19 at encode 4, MOVCL, BL MOVBX, 1 push disub D, 1 at encode 5, call insert node inc bx dec de cmp bx, fjb at encode 5 pop de call insert node at encode 6, movx, match len cmp al, cljb at encode 7 mov al, cl mov match len, AX at encode 7, CMP. AL, threshold JA at encode 8 MOV match len, 1 or byte PTR code buff, CHMOVBX, DX push SI lay SI text buff P add SI DMOVAL byte PTRESSI pop SI MOVAL byte PTR offset text buff and DMOV byte PTR offset code buff and BX, ALINK DX JMP at encode 9 at encode 8, MOVBX, DX MOVAL, byte PTR match POS MOV byte PTR offset code buff and BX, ALINK BX MOVAL, byte PTR, match POS +1, push CX MOVCL, 4 SHLL, CL pop CX MOV byte PTR match len sub threshold +1 add al, MOV byte PTR offset code buff and BX. ALINK BX MOV DX, bx at encode 9, shlch, 1jnz at encode 11x or bx, bx at encode 10, mov Byte ptr offset code buff and bx call pusi inc bx cmp bx, dxjb at encode 10 mov dx, 1 mov ch, dl mov byte ptr code buff, dh at encode 11, mov bx, match len mov last len, bxx or bx, bx at encode 12, call guess cjc at encode 14 jc at encode 15 push ax call delete node pop ax push delay did text buff p add dsi stas pop dmov byte ptr offset text buff and si, al cmpsi, f, 1j at encode 13 push delay did text buff p add dsi mov byte ptresd and nal pop dmov byte ptr